Good evening. Well, thanks for inviting me here. First off, I'm delighted to be here. I live in Yorkshire, but I live like, if you head west, and it's the last village in Yorkshire before you hit the wall between Yorkshire and Lancashire. That's where I live at the moment. So it's not too far to come here. I'm very happy to be here. I thought that tech talk sounds really interesting. The beginner's tech talk. It's probably too late for me now. It's probably. So just a bit about me. So like I said, I live in North Yorkshire, but I work at Lancaster University and I also work at Lancaster Girls Grammar School. And in my spare time, which I don't have a lot of, I like to make things. I'm originally from Ireland, so I lived in the UK for 11 years now. I just want to talk a bit about my work at Lancaster University, because I know a lot of you have probably gone through the British system, education system. And you may not know, in 2015, we said goodbye to ICT. Many of you may have done an A-level or a GCSE in ICT, or maybe had lessons in it at school. So in 2015, the government removed ICT from the national curriculum and replaced it with computing. So this is computing as a whole subject. So ICT is actually still there. So a lot of people think we got rid of it, but it's still there. And brought in digital literacy and computer science. So the computer science bit is probably the bit that we all love, and it's the programming and the coding. So that joined to make a new curriculum. And it was there's an organization called Computing at Schools. This is an organization of computing teachers. And they pushed for computing to come into the national curriculum. They wanted computing to come in. They thought ICT was rubbish. It was just all about Word, Excel, and PowerPoint. And they pushed, and unfortunately, they got their wish. But they got it very suddenly. So there was no kind of transition period. There was no training for teachers, because quite a lot of ICT teachers were just business teachers in disguise. So like the business teachers teaching Word, Excel, and PowerPoint very happily now suddenly have to teach computing. And again, it's even worse for primary schools. So you got primary school teachers having to teach computing with no background in computing whatsoever. So computing at school, the Department of Education decided to fund computing at school, and their job is to help teachers teach computing. I say teach a lot in my job description. So I work at Lancaster University at the Lancaster University CAS Regional Centre, Lancaster University Computing at School Regional Centre. And there are 10 regional centres around the country. We're quite well stocked up north. So Lancaster University, University of Manchester, we cover the northwest, York and Newcastle, kind of the northeast. And we run conferences and we run teacher training events just to try and boost teacher confidence in the subjects. That's one of my jobs. We also recruit master teachers. These are your computing teachers who have a background in computing and are confident to teach other computers, because the scale is just huge, and the areas that we all cover. So up in Lancaster, we cover Carlisle to North Liverpool. So we cover the whole West Cumbria, the whole West Lancashire, and we even go into Settle and Skipton. So the region is huge, 800 schools. We're never going to be able to support every teacher in every school. So we try and scale it. So we train one teacher to be good, and they train 3 teachers to be good. And that's what I do. So I thought you might find it interesting where computing is going in schools now. So we should see better computer scientists coming through schools, because they've also dropped. When I did first year computer science degree, that is now what they learn at A-level. So they're bringing the content lower and lower into schools. So it's an interesting development. And at kind of the same time that this happened, that computing came in, the BBC created the BBC Microbit. And this is a tiny little microprocessor. I'll show you in a second. All these partner companies helped develop the Microbit. So you can see here, the main one that I'm looking at is Lancaster University. So before I came to Lancaster University, my boss helped develop it. He helped actually program it and develop the application there. So when I arrived, I had access to lots of microbits, which is great, because this was before the schools had them. So I've had very early access to them, and I've had access to a lot of them, and they're not mine, and I haven't paid for them, so I'm very happy to break them. This is why I use the Microbit. It's one of the reasons why I use the Microbit, is because they're free. to me. This is what is in a microbit. Look back. Two little buttons, 25 LEDs. They're sensing LEDs as well, so they can sense light as well as emit light. It has a compass, an accelerometer, so it knows when it's being tilted and shook. It has a temperature sensor, but it's more the sensor of the board, so it's always hotter than you think it is. A radio, which is really interesting, I'll come back to that, and it can be connected through Bluetooth as well. All for the low, low price of $12.60. That's my sales pitch, okay? And that's what it is. So I'm going to talk about what I've made with the microbit so far. So I've kind of been working on little projects for over a year. When I say NeoPixel, I don't mean NeoPixel. NeoPixel is a brand name like Hoover and Heinz. So NeoPixel, it belongs to a company called Adafruit. It's actually a WS2812B, which is really easy to say. Individually addressable red, green, blue light. So when I say NeoPixel, that's what I mean. But I do use NeoPixels in a few things. So this is the microbit here connected to an edge board. So when I started, I kind of developed how I was connecting things. So I started off with the edge board. The edge board is another £5 on top of the microbit. And it has pointy pins, so it lets you connect female jumper wires to it. And these are actually NeoPixels connected to it. So I connected them in a chain to a microbit. And it was Halloween, and my son had a Halloween party at his school. So I had a really bizarre moment where I had a vice clamped to my sitting room table with an umbrella connected to it and a lot of glue. It was a very happy evening in my sitting room, and some fluff. And it was a storm cloud. So the lights would flash underneath, and it looked really good. I've put some videos up at the end, and you see it looks really good when you see the video. And we won a bottle of champagne for that costume that you carry. That's how I started, and that is the NeoPixel. So that's a breadboard-friendly NeoPixel. You have to solder pins onto that to connect onto the jumper wires. I don't use them anymore because you have to solder. I try and create projects that children can recreate. So soldering is just beyond a lot of their skills, beyond a lot of teachers as well. Not everyone can solder. Not everyone wants to solder. If they came pre-soldered, that'd be brilliant. You know, they'd work really well. But they are expensive. They're like £1.50 for each light. And when you want to make big, fun things, it's not good. So that's where I started. Then I made BFG Dream Jar. Again, my son entered another competition and Mum took over. It was a World Book Day. So the BFG, we all know who the BFG is, yeah? The big friendly giant. And he has a dream jar that he carries around with him with the dreams in it. So my son went he had big ears, and he went waistcoat, and he went as the BFG. And so I had some bubble wrap. And these are the Crumble Sparkles. So the Crumble is another microcontroller board that was out before the microbit. And they created these sparkles, and they're quite big, and they connect with crocodile clips. When the crocodile clips touch each other, the light goes away. But for this setup, so for the bubble wrap, the light wasn't moving. So it worked well for that. They're cheaper lights, and there's no soldering. So I like the sparkle if you have a static project and you can chain them all together. But crocodile clips can be dodgy. They can not work. You can see I've kind of developed better ideas of connecting things. These are my stair lights. Everyone loves the stair lights. So I went to Pi Academy and I learned a bit about the Raspberry Pi, and everything I do is with lights. So this is my big light project. These are my stairs. This is my house. It's connected to a Raspberry Pi Zero underneath the stairs. That connects to the internet. It gets from an API. It gets the current outside temperature for the longitude and latitude of my house. So it tells me what temperature it is outside. It's very grim in winter. So when it's less than 0, only these white lights come on. When it's less than 5, the white and the blue lights come on. So it's every 5 degrees, so you say 5, 10. At the moment, we're still getting green, which is brilliant, so in North Yorkshire. So when I come downstairs in the morning, and my little 5-year-old comes down, he's like, yes, it's green. because that means it's between 10 and 15 degrees outside. This happened for 5 minutes in July. It was 26 degrees. It was brilliant. And it refreshes every 5 minutes, so the lights go da-da-da-da-da. You're like, oh, green. No, it doesn't quite get to green. But I might reverse it, because in the winter, it's just white, and it's just miserable. So I might actually make mine as 0 to go up to red, because that's more fun. But yeah, they were really popular, that project was. And that is with a strip of WS2812Bs. The Adafruit version of that would be about £60, but the WS2812B version was £22. And I've seen it for cheaper, I've seen it for 15. That is 260 lights going up my stairs. So very easy to connect as well. And since then, that's what I've been using. I'm using these lights, these strips, because they're just much easier and cheaper than the actual NeoPixel. My son is a fan of Power Rangers. This is a Power Ranger sword. So basically, those 260 lights, I just cut off a section, stuck it onto a wooden sword. And when you tilt it, it goes red. When you tilt it right, it goes green. And then blue, the different colors of the different Power Rangers. If you have toddlers, you'll know Power Rangers. And a belt. Again, so it's just a mobile version of the stairs. You just cut off another strip of lights and connect the battery to it. And then we got onto the jacket. So we really wanted to make a jacket. So I started cycling to work, the last 2 miles to work, and I really wanted to make something practical, because the stairs are kind of practical, but something that actually was practical that people would use. And I spent a long time planning this, because I wanted it to be a real thing that people would use. And I started off with sewing NeoPixels. So this was the idea. So you've got the Microbit there with a battery, and this is sewn into some material called cross stitch, which is like little square grids. Can you see it's a left arrow? Yeah, and that's the right arrow. It's the same lights, but left arrow, right arrow. And this is with actual Adafruit NeoPixels, again, expensive, £1.50 each. But you sew with conductive thread. So conductive thread, your ground, your positive, and your data, and you chain them together. The wires can never cross, or it won't work. And that's the neatest sewing I've ever done in my life. And it worked when it was static on the table. Once you pick it up, and like I was going to attach it to my back with like poppers. But once you moved it, it kind of flickered. And it didn't work, and the signal wasn't great. And it was gutting, because it took me hours to sew this. And those lights are expensive, and the thread is expensive. So having to pull all that out was really frustrating. And I spent weeks on this jacket. So that was take 1 with the sewable. And this is take 27. So this is just a strip of lights from my stairs. The problem is when you bend the lights, it can crack the connection. So this take 26 was the same, but I bent the lights, so it only the first 4 lights lit up, and then the rest of it wouldn't work. So you just have to be gentle when you're bending the lights, and that's how it works. So in kind of the arrow shape, and I need a model. Who's going to volunteer to model? Matthew? No? Claire? Yes, oh, there we go. So, yeah, you can just try. Hang on. So through there, yep. All right. Hang on. Ooh. Yep. Okay. Yep. So it's still kind of a prototype. Like, I wouldn't bring this out in the rain. So I'm going to have to touch you. Sorry, I'm just going to have to. So we have a microbit in your shoulder here, and the battery is sewed very badly there. So we're just trying to, sorry. I'm just going to plug the battery into the microbit. Hang on. It's just a normal kind of JCT connection, JCT, with two AAA batteries in there. And then the lights is on a different battery, which are there. This battery's got a switch on it so it can save power. And do you want to turn around so everyone can see? Is it going to work? Right now, I'm just going to do it manually. So we're going to press A on the Microbit, which should have been left. But yeah, this arrow is not perfect because it was a bit of a rush job. So I know it flashes for too long, but then if we press B. So I was trying different colors out. I kind of like the orange, but the purple's a bit funky, you know. People get very political on Twitter, as you may have found out. And I was like, blue would be awesome. But I'm like, you can't have blue. The police have blue, you can't have blue. I'm like, okay, that's a bit weird. Yeah. So that's the jacket, and the idea is on the handlebars then you would have another microbit and you use that radio connection I was talking about. So the microbits can be paired together, not like Bluetooth. So basically this microbit's on channel 33, this microbit is on channel 33, and and it just works, there's no pairing. I just plug that in, it has no kind of saved pairing, and that's the best bit of the microbit I like. It beats the Raspberry Pi, it beats any other microcontroller out there because of the radio, because you can do wireless things like this. It is a lot of fun. So the idea is that this would go on my handlebars, and I could easily indicate which way I'm going. And I've had like runners as well say it to me. You know, they'd like it on their sleeve as they're running. I'll do one more demo. It's not really an arrow, is it? It's not really the shape of it. It's not really an arrow.
Can I ask a question?
Yeah, sorry.
What kind of range is it then, the radio?
The range is quite far. I think what Simon Monk said. I can't remember what he said. Do you remember? 8 foot? No, it's much further than that. So we've had a lecture theatre of children. We had 100 children, and they each had a microbit and the presenter, and they all voted. So in a theatre, they all managed to reach him. Philip, do you know?
Actually, interestingly, it was limited in the first instance.
Yeah.
BBC were a bit nervous about the range being too far, the potential for bullying and things like that. So there are ways, your boss from Lancaster, Joe, will know, you can actually dial the power up. But we tested it in a big open square, and the lowest setting it would go about the distance that Simon mentioned. So
Yeah.
I think the potential to go much further is there.
Yeah. But this kind of demonstration, do you want to, you can stop modeling now. Do you want to take it off? Thanks very much.
Yep.
Yeah. For the model.
I'd buy one of these if you sold them. I think
Oh, right,
cool.
right. Awesome, you've been my first customer.
Yep.
So for this kind of model, you don't need a long range. But you can connect quite a lot of microbits to one microbit. So we had, like I said, the lecture theatre, Joe, was, he was giving a talk to students, and they said, are you having fun? Press A if you are, press B if you're not. And he had a live graph of 100 microbits telling him the answer. So there's loads of potential for that radio. I've lost my remote. I put it. My clicker. Oh, there it is. And that's upside down. Code. So again, like I said, I make everything that can be reproduced by children. So I can go into a class and they can all make this. They don't need any special soldering skills. They don't need any crazy programming skills. So I keep it really simple. So you can code the microbit in Python, like a MicroPython. But this is just using blocks, and it's called Microsoft Make Code. It's all online. You create your code online. And has many people seen Scratch? If you're a teacher, you hate Scratch because it's very popular. It's a block-based language. So you drag your blocks from the menu. And this is the same idea, using kind of the same level. So I set up my lights. I set up a variable. I set it to my lights. I set them to pin 0. So the microbit, without the edge connector, has 3 pins that you can connect to. I've got 30 LEDs that are RGB. When I press button A, clear my lights, and then all the lights will go red. And that's it. So using just those simple blocks, you can start coding the strip of lights. And this is the radio code. Again, just really, really simple. set the group to 33. When I receive a number, if the number is 33, don't know why I use 33 again, call function /left, call function /right. So you can add functions, you can add variables, you can add loops. You can build up their programming kind of confidence with blocks before you go into a text-based language like Python. And this is the handlebar remote code. So that's the code for the microbit that sits on the handlebar. So when I press button A, send the number 34. When I press button B, send the number 33. And that's how the radio works. And it's beautifully simple. You don't have to know any Python to do it, which I love. So I just finish and walk away. Thank you.